Okay, we're ready to work on page 8, lesson 7, module 2. This activity is contrasting rate of change for linear models. So as you hopefully remember from previous videos, rate of change is really just slope. So when they're asking us to find the rate of change, they're asking us to find slope. And back in module 6, we learned 2 different ways to find slope. One way we learned was counting the squares. The other way we learned was using the 2-point formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So just for practice for our test, let's go ahead and do both ways, because I'm hoping if you have time on the test, you will. As many times you can catch errors by doing that. So the most common way to do rate of change with a graph, as we learned in module 6, was rise over run. And order does matter. The rise has to be in the numerator because rise is where the y's go. Notice the x's go by 2, or excuse me, the y-axis goes by 2s, 2, 4, 6, 8. And so does the x, 2, 4, 6, 8. So be mindful of that as you're counting. We learned in module 6, you always start with the left-hand point because we move left to right, just like we read a book. So rise first, so rise 2, 4, 6. So our numerator is going to be 6. And our run is 2, 4, 6, 8. So just like any other fraction, it does have to be simplified for the final answer. So we can see here that these are both even, so that means they're both divisible by 2. So that gives us a final rate of change of, let's put it up here, 3 over 4. So now let's try the point method and see if we get the same answer. So remember, using points, our formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So that means we need to label our 2 points. So this one, x is negative 2, y is positive 2. And on this point, x is 2, 4, 6, and y is 2, 4, 6, 8. So the second y minus the first y, 8 minus 2, over the second x, 6, minus the first x, negative 2. Don't lose that double negative there, because the minus comes from the formula, and then the negative 2 comes from the coordinate. So that leaves us with a rate of change of, we learned way back when double negatives always turn to a positive. So that would be a rate of change 8 minus 2, 6, over 6 plus 2, 8. Divide both by 2 again, and voila, we just checked our work using the graph. So using the graph, we got 3/4. Using the 2-point formula, slope formula, we got 3/4. So then you can walk away and go, yes, I know I got that one right on the test. I did it 2 ways and I got the same answer both ways. And unless they tell you otherwise, you can use whatever method you like on the test. But if they tell you a certain method, make sure you do use that method. Okay, on B, we have several line segments. And it looks like some of the letters got lost here or weren't dark enough. So this is D, this is C, this is line segment B, and this is line segment A. So for this one, we need to find 4 different slopes. This line will have one slope, this line will have another, this line will have another, this line will have another. So we'll have to do slope 4 different times on this problem. First thing I look at before I start counting my boxes is that the x's are going by 1, and on the y-axis they're also going by 1. So let's go ahead and do the counting method on these, because usually that's what students are the weakest at, and it's really the fastest way to find the slope. So we're going to try and get good at it. So rate of change for A, the rise over run. So we always start with the left-hand point and travel to the right hand. Remember how we learned in Module 6, when the line falls from left to right, it's going to have a negative slope. When it rises from left to right, it's going to have a positive slope. So I can tell this one's going to be negative. We had an activity earlier in this packet. We learned horizontal lines are always 0 because nothing's changing. They're saying the same distance from home, or whatever it is you want to call it. Here, my line is rising, so that should be a positive answer. Here, my line's falling, so negative. So keep that in the back of your brain as you do it, and then you can kind of check and make sure you're on the right track. So traveling from left to right, I first rise, so go down 1, 2, 3, 4, 5. So when I go down 5, that makes that negative 5. So 1, 2, 3, 4, 5. So I went down 5, and then I'm going to run 1, 2, 3, 4. So down 5, run 4. Did that meet our prediction that it would be a negative slope? Yeah. So when we go up, it's positive. Like on the last one, going from left to right, we went up 6 and ran 8. But on this one, we went down 5. That makes it negative, and ran 4. So 1, 2, 3, 4, 5 down, 1, 2, 3, 4 over. So there is our first rate of change, negative 5/4. I'm going to move it over a little bit so I don't run out of room like I almost did there. So now line segment B, we don't have to do any rise over run. We don't have to do anything if we don't want to. We can just say 0. But if you were showing your work, let's say, and you wanted to do rise over run, you'd still get the same answer. So from going from the left point to the right point, I rise 0 and I run 2. Well, what's 0 over 2? 0 divided by 2 is 0. And if you get mixed up which one's undefined or which one is 0, all you have to do is type it in your calculator to verify. Keeping it in the correct, oh, look at that, it's right on the screen. Keeping it in the same order. So that must have been from another problem. So 0 divided by 2, yep, it's 0. So if the calculator gives you an error, that's when you do undefined. But a lot of students will type it in backwards and they'll go, oh, my calculator says undefined. You can't do that with division. Division is not commutative. You can only do numerator divided by denominator, top divided by bottom. Order matters. Okay, C, we predicted that the slope would be positive because that line is rising. So going from left point to right point, we're going to rise 2, run 2. And so it is indeed positive. We rose 2, ran 2, so the slope of that line is 1. And last, D. So the rise over run, so we can find the rate of change or slope. So traveling from the left point to the right point, notice we're going down, so that tells us the slope's going to be negative, which it should be because the line's falling down. 1, 2, 3, 4, 5, 6, 7. So down 7 means negative 7. And we're running 1, 2, 3, 4. So negative 7/4 it is. So down 7, going from left to right, run 4. And I will tell you the biggest mistake on this on tests is students run and then rise. It's alphabetical order. Rise must be the numerator. Run must be the denominator. So that's why I always write this, encouraging students to do the same thing so that you don't get the order backwards. So rise first, run second. Rise is the numerator, run is the denominator. Okay, we don't need to do this C question. That's a goofy question. So let's go ahead and go on to the next page. So this kind of gives you an idea of other things that rate of change do. We saw they talk about how fast a car moves, but we can also talk about how fast money's leaving our account, how fast our money is growing, how fast a record's turning on a turntable. So rate of change can mean a lot of things. So this one is going to be dealing with money. So on the 18th birthday, John's family gave him the rights to his college savings bank account. So let's go ahead and highlight the important stuff. John started making withdrawals of the same amount. So that's pretty important, knowing that it's the same amount. That makes it a line. Remember, constant rate of change is a line. So that tells me this is a linear function. If I were to graph it, it would look like a line because it's the same amount each time. So after the third withdrawal, John's account had $25,000. So the minute I see this problem is rate of change, my head says I need 2 points. Just like when we were doing those problems as a warm-up with Pedro and the roller coaster and the pizza and the internet, we always had to start with 2 points. So this tells me find 2 points, because that's how we do rate of change when we don't have a graph, right? y2 minus y1 over x2 minus x1. So that's what that tells me. So now we have third withdrawal, $25,000. So that tells me this is the first point. And we don't have a time here. So third is kind of time. And I told you time goes first, but if I can't really see one that's time, I just keep it in the order they gave me. So this is the withdrawal number. And this is the account balance in dollars, because we're going to need that. Remember, whenever we have to talk about rate of change, we need a label on it. On the last graphs, because I've had students in class go, why didn't you label these y per x? Well, I looked at the axes, and the axes didn't have any labels on them, so that's why I couldn't label them y per x. But these have labels, so that's why our rate of change not only has to be a simplified fraction, but it needs to be labeled y per x. So seventh withdrawal, $3,000. So 3,000. And since he's withdrawing, I want you to start thinking about these things. Do you think the rate of change is going to be positive or negative? Negative, right? Withdrawal means his account's going down, as you can see that it is. So in my head, I'm thinking, oh, when I go to do the slope or rate of change, I better make sure it's negative. It should be. So how much was John withdrawing each time? Isn't that called the rate of change? What is the amount of each withdrawal? How fast is his account changing? So we'll be finding the rate of change, which says take the second y minus the first y over the second x minus the first x. And that gives us negative $22,000 over 4. So that is